After the completion of fatty acid synthesis, now we will discuss about regulation of fatty acid synthesis. Objective of this session is, at the end of the session, the learner should be able to describe regulation of fatty acid synthesis. The fatty acid synthesis is regulated at many points. What are these? Okay, one is diet. What the diet contains. The second one is citrate, the levels of citrate. The next one is acetyl, the enzyme acetyl coenzyme A carboxylase. Okay, then the next one is hormones. Hormones play very crucial role. Okay, the next one is the levels of serum free fatty acids. Serum free fatty acids, the concentration of serum free fatty acids. Okay, the next one is availability of NADPH. NADPH is required. Okay, of course, acetyl coenzyme is also required, and these are the factors which are having influence on the synthesis of fatty acids. We'll discuss one by one. The first one is diet. If there is high carbohydrate diet, so what happens when there is high carbohydrate diet? So glucose at the end of the metabolism, so converted into acetyl coenzyme A. So that is to the pyruvate. So there will be increased levels of acetyl coenzyme A. When there is high availability of acetyl coenzyme A, there is increased synthesis of fatty acid. That is the influence of high carbohydrate diet. Suppose somebody takes fat-rich diet. What happens? So there will be decreased fatty acid synthesis. Okay, so that is the effect of high carbohydrate diet and high fat diet. Then the second aspect is citrate. Citrate is an intermediate of citric acid cycle. When there is high citrate is present, so there will be increased activity of acetyl coenzyme A carboxylase. As you know, acetyl coenzyme A carboxylase is regulatory enzyme. Then the fatty acid synthesis increases. Fatty acid synthesis is increased. The next aspect is acetyl coenzyme A carboxylase. The crucial enzyme. So this enzyme can be in active form and inactive form. Okay, there are two ways the enzyme is controlled. The first one is covalent modification. By addition of the groups, covalent modification is taking place. So once covalent modification is taking place, the enzyme may be active or inactive. Let us see here. So this is acetyl coenzyme A carboxylase. Okay. This is acetyl coenzyme A carboxylase. Okay, carboxylase. This enzyme is active enzyme. Covalent modification by addition of the phosphate group, we can do it. Okay, covalent modification by addition of the phosphate group, we can do it. Okay, let us add the phosphate. Then what happens here? Let us see here. Okay, so let us see here. So this enzyme, what it becomes? This is acetyl coenzyme A, carboxylase. This is inactive. Why it is inactive? Because phosphate group is added. What is the next one? Allosteric control. Okay, the first one is covalent modification. The next one is allosteric control. Again, so what happens here? The acetyl coenzyme A carboxylase, that is the crucial enzyme, coenzyme A carboxylase. So this enzyme is the crucial enzyme. This enzyme inhibited by palmitic acid. What is the palmitic acid? The end product of fatty acid synthesis. The end product of the fatty acid synthesis, palmitic acid, is inhibiting the crucial enzyme of the fatty acid synthesis. This is what we call feedback regulation. Okay, we call it feedback inhibition. Okay, then the fourth one is hormonal control, or we can say hormonal action. If there is increased plasma insulin, then what happens? So lipogenesis is increased. Fatty acid synthesis is increased. What happens in the fasting state? Okay, so there are increases in epinephrine and glucagon. Okay, so when their levels are increased, what happens? It is not the lipogenesis. It is increase in lipolysis, breakdown of fat. What is the mechanism? Again, let us go back to acetyl coenzyme A carboxylase. The acetyl coenzyme A carboxylase, as I said, can exist in two forms. One is active form, the other one is inactive form. Okay, let us see. This is acetyl coenzyme A carboxylase. This is inactive form. So this can be converted to the active form. So by removing the phosphate group, it is simply acetyl coenzyme A carboxylase. Okay, here there is no phosphate. It is active. So in the fed state, in the presence of insulin, what it does, insulin, it activates the phosphatase and then phosphate group is removed. So becomes active. It happens in the fed state. What happens in the fasting state? Okay, in the fasting state, this is fasting state. As I said, fasting state, there is increase in epinephrine and glucagon. What happens here? Phosphate group is added through the protein kinase mechanism. So active to inactive, active. One group of hormones making it active, another group of hormones making it inactive. The fifth one is effect of serum free fatty acids, non-esterified fatty acids. If there is increased serum free fatty acids, free fatty acids. Okay. So then there is decreased fatty acid synthesis. Okay. So finally, it is the role of NADPH. Availability of NADPH. The availability of NADPH is very crucial because it is a reductive synthesis, fatty acid synthesis. NADPH has to be there. If there is availability of NADPH, fatty acid synthesis will continue, or else it will not. One of the supplier of NADPH is HMP shunt path. Okay. This is about the regulation of fatty acid synthesis. In this session, we have discussed about the regulation of fatty acid synthesis. So let us draw some important points. Fatty acid synthesis is well regulated. Regulation by dietary intake, citrate, hormones, serum free fatty acids levels, availability of NADPH. Acetyl coenzyme A carboxylase is a regulatory enzyme regulated by covalent modification and also allosteric mechanism. Okay, so carbohydrate diet intake, if it increases, synthesis will increase. The fat rich diet decreases the synthesis. Increased citrate increases the synthesis of fatty acids. Okay, increased insulin increases the fatty acid synthesis. Okay, increased glucagon and epinephrine decreases it. Increased serum free fatty acids decrease the fatty acid synthesis. If NADPH availability, if it is there, there will be increase, or else so there will be decrease in fatty acid synthesis. So these are various important points regarding the regulation of fatty acid synthesis. Okay, thank you very much.